So this problem is problem number 4 from Newton's second law and problem solving worksheet that I gave you, and this was the worksheet that I gave you particularly to use as review for the upcoming tests that you have. So I'm hoping that you started this problem by drawing a free body diagram and using a coordinate system. So this says 6.58 times 10 to the third Newton upward tension force is exerted on a 5.21 kilogram downward moving freight elevator. Determine the acceleration of the elevator. So we have some important info here. There's a tension force that's upward, and they give us the amount. It's a 521 kilogram downward moving freight elevator. And we're being asked to determine the acceleration of the elevator, so that's going to be the net acceleration. So let's take a minute, draw the free body diagram, and the forces we have acting on it. We have a force that's acting down, it's force of gravity, and then we have a force that's acting up as well, and that's going to be the tension force. Now the question is, which is bigger, tension or gravity? It tells us here that we've got a 521 kilogram freight elevator, which means it's got a mass of about 521 kilograms, and you know acceleration due to gravity is about negative 9.8. So if we round that up to 10, 521 kilograms times 10 meters per second squared is a little over 5,000 newtons, and this is a tension force of 6.58 times 10 to the third, or over 6,000 newtons. So tension clearly should be bigger than the force of gravity. Let me erase the force of gravity a little bit here to make that a little clearer. And that's supposed to be a straight tension force. It may have an angle. That's my drawing issue. So I'm going to go ahead and say up is positive and down is negative. And let's start by writing our F net equation in the y direction. And we only need an F net equation in the y direction because we're only dealing with the y direction in this problem. And for the record, when you see the force of tension, it's okay to just say T as well. So I'm going to call the force of tension T plus the force of gravity, or the weight of the elevator. So these are the forces. Now this is a situation where these forces are not equal and opposite. We can clearly see one is bigger than the other, so these are not going to equal 0. The F net in the y direction should not equal 0 in this problem. Let's take a minute and write down things we know. We know that the tension force is going to be, I'm going to call this just T again. Instead of F tension, we're going to start calling tension just T. The tension force is going to be 6.58 times 10 to the third newtons, and that's upward. We know the mass is 521 kilograms. And I'm going to write a little v over here so we know our velocity vector is actually going to be downward because it tells us it's a downward moving freight elevator. So I have mass moving down, I have tension, and I don't know my force of gravity yet, but I do know acceleration due to gravity is negative 9.8 meters per second squared. And there are a couple of equations that we always know to be true. We know force of gravity is equal to mass times acceleration due to gravity. We also know F net equals ma net. Okay? So let's go ahead and think about this. We're trying to find the net acceleration. That's what the problem asks us for. In order to find the net acceleration, we need to know the net force. So if we go back up to our F net equation, the only way to find the net force is to know, in this particular case, is to know tension and force of gravity. We already have the tension, it's right here. So that's the good news. We don't have gravity, but we can find it. So let's go ahead and take a minute and find the force of gravity. Force of gravity is mass times acceleration due to gravity, and we have both of those pieces of information. Mass, 521 kilograms. Acceleration due to gravity is negative 9.8 meters per second squared. So take a minute and do the math and tell me what you come up with. Hopefully you got negative 5,105.8 newtons. That's the force of gravity. So it's acting down right here with a force of negative 5,105.8 newtons. So to find our F net in the y direction, we simply need to add our tension and our gravity together. So tension was 6.58 times 10 to the third newtons. And I'm going to add that, I'm just writing below it because I'm running out of space, to negative 5,105.8 newtons. And here's a helpful hint. When you plug this in your calculator, if you have a TI, particularly if you have a TI 83 or higher, when you plug scientific notation into your calculator, what you want to do is put in 6.58, just like it's written, but then instead of saying times 10 to the third power, go up to your second button, and the second button is usually on the top left corner. Hit the second button, and then go back to the comma, and above the comma you should see an EE. That's your exponent button. So if you hit the EE and then put a 3 in, you're going to see something in your calculator that looks like this. It's going to be 6.58 E3. And that is your calculator's way of saying 6.58 times 10 to the third. And that's a lot easier than having to put in a 6.58 and then a times 10 and then a caret button and then a 3. Just use your EE button from now on into the future. And if you're not using an 83 or an 84 or an Inspire or something like that, you should still be able to have, or somewhere on there should still be that EE button. So now when I add these two together in my calculator, I come up with a net force of 1,474.2 newtons. And I get a positive. Hopefully you got a positive as well. What that's telling us is the force of tension is bigger than the force of gravity. So even though the elevator's moving down, the net force is a positive force because tension is bigger. So here's what that's saying. They're unbalanced forces because there's a net force, and we still don't know what the A net is or what the net acceleration is. So we still know the rule that, or Newton's second law, that F net equals MA net. If we want to find MA net, now since we know F net, how about we just divide out mass on both sides? So F net equals, F net divided by M equals A net. So the net force, or 1,474.2 newtons, divided by a mass of the elevator, which was the 521 kilograms, is going to equal the net acceleration. So when you do the math, you should come up with 2.83 meters per second squared. And we get meters per second squared because kilograms times meters per second squared is equal to a newton. So kilograms cancel and you're left with meters per second squared. So take a minute and look up at your problem. We had 3 sig figs, 3 sig figs. The answer is 3 sig figs. We're good to go. Now here's the thing to think about. This is a little bizarre because the elevator's moving down. It told us that, but it has a positive acceleration. So what that means is even though the elevator is moving down, since the net acceleration is up, as the elevator moves down, it's slowing down because the signs are opposite. Okay?